Hello and welcome on YouTube channel of Lalbagh Girls. Myself Kirti. Today I am going to teach class 10th maths and the topic is polynomial. This is exercise 2.1 and question second. So I read a question for you. The question is, find the quadratic polynomial, the sum and the product of whose zeros are 6 and 9 respectively. Hence find the zeros. In this question you have to find the quadratic polynomial, then find the zeros. So students, I'm write a formula which help you to find the quadratic polynomial. The formula is quadratic polynomial x square minus sum of zeros x plus product of zeros. So by this formula I am going to find the quadratic polynomial. Here in this question we have to given the sum and the product of zeros are 6 and 9. So I write as sum of zeros is 6 and product of zeros is 9. So I can write these on this formula and get a quadratic polynomial. Therefore x square minus sum of zeros is 6, so 6x plus product of zeros is 9. Hence this is the quadratic polynomial. Now next is find the zeros. So how can find the zeros of this polynomial? I am going to split this quadratic polynomial and then find the zeros. So x square minus, I can write it as x, write in bracket, plus 9. I can factorize 9 as become it is split in two groups, and then adding or subtracting these groups we get the middle term. So the 9 is 3 into 3. So if we are going to add 3 plus 3, we get 6, and multiplying this number we get 9. So I'll take 3 plus 3. X square minus 3x plus 9. So I'm going to split these into two groups, and the common term in these first group is x. So x bracket x minus 3, and here the common term is 3 minus 3. So minus 3 and then bracket gives 3x minus 3. So x minus 3 and x minus 3. So this is the solution. Okay. Now the zeros of this polynomial is, if we take x minus 3 is equals to 0, then x is equals to 3. So this is the zeros of the quadratic equation. And in the second, if x minus 3 is equals to 0, then x is equals to 0. 3 So the zeros of the quadratic polynomial is 3 and 3. Third question is verify whether 2, 3, 1 by 2 are the zeros of the polynomial px 2x cube minus 11x square plus 17x minus 6. In this question there are 3 zeros and I'm going to verify these zeros is actually the zeros of this polynomial. So taking 2 as a 0, first we have to take 2 as 0. Then x is equals to 2. Putting these value in the polynomial, and after solving this polynomial we get 0. If the polynomial becomes 0, so these 0 is called as zeros of the polynomial. 2 p2 is equals to 2 to the power cube minus 11 2 to the square plus 17 into 2 minus 6. Then 2 into cube of 2 is 8 minus 11 into square of 2 is 4 plus 7 2s are 34 minus 6. 2 8 16 minus 44 plus 34 minus 6. Now solving these expression, if we are going to subtract 44 and 66, we get minus 28 and get plus 28. So subtracting minus 28 plus 28, it's 0. So hence we say that 2 is a zeros of the above polynomial. Hence 2 is zeros of the polynomial px. Now similarly applying these process in 3 and 1 by 2 and verify the zeros. I'll taking 3 as a second zeros, then putting x is equals to 3 in the polynomial px, then p3 is equals to 2 3 cube minus 11 square of 3 plus 17 into 3 minus 6. 2 into cube of 3 is 27 minus 11 into square of 3 is 9 plus 17 threes are 81, 51 minus 6. Multiplying 27 with 2 we get 2 7s 14 1 54 minus 99 plus 51 minus 6. Okay. Subtract 99 and 54, we get minus 45 and plus 51 minus 6 gives 45 plus. So this is the value 0. So 3 is also a factor of the above polynomial, right? Hence 3 is a zeros of the polynomial. Normal P(x) is also a zeros of. Third is 1 by 2. Now taking P as x as 1 by 2, then 2 1 by 2 whole cube minus 11 1 by 2 whole square plus 17 into 1 by 2 minus 6. So 2 into the cube of 1 is 1 and the cube of 2 is 8 minus 11 into 1 square of 1 is 1 and square of 2 is 4 plus 17 upon 2 minus 6. Cutting 2 with 8 get 4. So there is a 1 upon 4 minus 11 upon 4 plus 17 upon 2 minus 6. So I'll take an LCM of 4 and 2 gives also, we know this is the 4. Make a line and get an LCM is 4. Then here 1 minus 11 plus 28 minus 6. सॉरी यहाँ पे 26 नहीं 24 sorry. Okay, now this is the 34 1 minus 11 plus 34 minus 24 upon 4. So this is minus 10 plus 10 upon 4 is 0 upon 4 and 0. So we can say that 1 by 2 is also a zeros of the polynomial. Now here is a complete solution of this question. This is the complete solution of complete. This is the complete solution. Thank you.